Hello and welcome to the Professor Vector channel. My name is Ed March and we're going to look at using Blender for 3D printing. Okay, so you just got a 3D printer and you're looking for some kind of CAD program. There's a lot of STL files you can download from Thingiverse and other places on the internet, and you can print other people's designs, but how do you make your own designs? And what CAD software should you choose or use? And what should you learn? And Blender is free, almost. There's a few add-ons you may want to buy for about under $20, but they're worth it. So first of all, we'll look at the Blender workflow. Okay, because when I first got into this, I wasn't even sure, what do I do with this 3D printer? What kind of files does it print? Okay, I heard about GCode, and my son had a 3D printer when he was 10 years old, and he was always printing some kind of test patterns and talking about slicers, and I was very confused. So the workflow. Your CAD programs will create DWG files, DXF files, like from AutoCAD. VC3D is used by PunchCAD. 3MF is a newly designed format that's kind of compressed and zipped. And other programs will make their other proprietary formats, such as Blender will make .blender files, and FreeCAD will make FreeCAD files. And then what do you do with this? Well, you can export it to an STL or an OBJ file, and that's what the slicer reads. Now, we got to look at what's in these files first of all. Okay, so when you open up Blender, you're going to get a cube defined somewhere. And, you know, I know the cube is perfectly square. I have a rectangle. But the point is, this cube is defined, one way to define it is to define a face that's on the top, and a face is defined by a vertex. So there's basic building blocks in the CAD world, and they are a three-dimensional point, a point in XYZ space, and that's called a vertex. And then there's an edge, okay, and that connects two vertexes together. I'll go from object mode to edit mode, and you can see these orange little points. So that's a set of points. And then we have vertexes, which is a connection between 2 points. And then we have faces, which is a connection between 3 or more points. So we could have hexagon, octagon faces, we could have triangle faces, you could have just about anything. Now when you export this, so if you wanted to print this, you would export this as, let's say, well, typically an STL file, but there's other files that have more detailed formats, and they're easy to parse, and they're in ASCII. An STL file is in binary. It's very hard to explain the guts of it. I exported this file from Blender to blender-cube.obj. Okay, so we're going to open up our Blender Cube OBJ file in the Edit Plus editor, which, by the way, I'm going to give him a little plug because this is well worth $35. Use it all the time. editplus.com. So thanks. All right, so in here we have pound signs that are comments. We have a material, which we really don't need. I can show you how simple this can be. So we can delete all that. We have an object name, cube. I will call this my cube. We have a vector, a vertex rather, at X, Y, and Z, another one at X, Y, and Z, another one at X, Y, and Z. And if you count these, 1, 2, 3, 4, 5, 6, 7, 8. There is 8 points that make up that cube. You can think of the cube as 4 on the top and 4 on the bottom. There's 1, 2, 3, 4, 1, 2, 3, 4. Okay, we don't need, we're not going to talk about this. This is texture. and these are normals. We're not going to talk about that either. We're going to use materials. We don't need that, but we do need faces. And we can eliminate all that. So these faces are the vertex, which is V, and then the VT, which we deleted, and then the normal, which we deleted. So we can simplify all this. And you're saying, well, what is this? Well, this face is vertex number 1. This is your first vertex, and then 2, and then 4, and 3. So if you drew a closed polygon using all 4 of those points in the polygon, you would have a face, okay? Okay, and we're gonna keep doing this here. We'll just make a macro key. And we'll do our, oops. Not sure what happened in those last 2 there, huh? Something goofed up. Because we had double digits and I recorded my keystrokes for single digits. So this is 8426, right? And that's our smallest little modified OBJ cube. So we'll save this. We'll save this as my cube. And that defines a 3-dimensional object, okay? These are the materials for it that we deleted because we don't need that. So we're just going to look at this simple little cube and go into a slicer, then delete that, and open up mycube.obj, and it has failed. Okay, I saved this. I had a little typo in here. I fixed these, so this looks correct, right? All these numbers are going between 1 and 8 because we only have 8 points, and you know, this is the index 1, 2, 4, 3, 5, 6, 7, 8, right? And this is the faces telling you which one of those points you can use. Now the nice thing, if you're ever generating your own program, you can put in a bunch of V's and then you can do faces and you can put in more V's. You can intermix them. But generally, an OBJ file has a bunch of V's followed by a bunch of F's at the end, so they kind of buffer it and they keep track of it. So here we are. We loaded this into our slicer and we got this cube. Now just to show you that it really is this cube, let's modify one of these and change this to something drastic. Let's see, maybe we'll go with our last V and make it, these things are all close to 0, so if we make it 0.15 and do that, bang, we distorted it very nicely, huh? So that's what we did. We moved this point over. So that gives you an understanding of how Blender stores this, okay? So I can manipulate this object in Blender, store it as a Blender, export it as an OBJ, put it into my slicer. And can I print this? Well, yes, actually I could. we would take this and we would export this into G-code, and it would say, okay, to print this, it's 2 hours and what is it? 58 minutes. Then we could look at what this G-code is. Now, this keeps getting simpler and simpler and simpler from the computer's point of view. We took a three-dimensional object, which was a high-level cube. We, as a human being, think of it as a cube. But the 3D printer doesn't know how to print a cube. It knows how to move the head back and forth along X, back and forth along Y, up and down along Z, and it knows how to push out some filament, pull out the filament, and it knows how to make the bed hot, the heating element hot, and change the temperature of those, and stop and start. So it comes up to dumb movements. It just goes, you know, I'm a simple little robot. Tell me where to go and how much filament to squirt to make that cube. And the slicer also figures out, do you want it filled with anything? I mean, you can't make a hollow cube. How thick are the walls? Are they 1, 2, or 3 layers thick? All right. So when we take this and we export G-code over here, we're going to get my cube G-code. And this was generated by the Prusa Slicer. Okay. These are like base 64 image files so that you can have thumbnails, but they're really comments in the G-code. They don't do anything for the G-code. They do things for the G-code viewers. Okay, and this is what all the movements come down to. There's a lot of M commands in here that are just basically setting acceleration and feed rates and stuff like that. How fast do I move between going to the points? But the actual, this is a little line that it prints just to get the filament started. But all this is your move to this X location, move to this Y location, and extrude this much. Move here, move here, move here, move here. So it's just millions of movements. That's why it takes hours to print this, because that's what we're doing. We're just going back and forth. And all right, so these are layers. And as it goes back and forth, it's going to look like this. Okay? This is your slicer, and this can give you like a time-lapse view of where the head's going to go and what it's going to do, and the G-code that it's processing to do that. So we're going back and forth, and we're filling it, okay? Because you can't make a hollow cube. Now the fill is set to 15%. We can set our fill to 5%, and you can see there's a lot less fill than this, okay? It's a little bit faster, not too much. You can change your fill type. Like your infill here right now is, I like to use triangles because they're the strongest, okay? So that is a bunch of triangles. See these walls? They're so thick. You can set all this. There's thousands of, not thousands, but there's dozens and dozens of parameters that you can set along and mess with this stuff. And, you know, if you say, well, that's not going to be too strong, depends what I'm making. I might want something 60% fill. You know, I usually never do anything like that because that just increased the time now to 6 hours. But usually you stay in your 15 or 20%, all right, 25%, and that's usually enough. So that is the workflow from CAD program that stores this as a Blender file, and then you export it out to an STL or an OBJ. You go into your slicer, you import that STL and OBJ, and you take that G-code that it exports after you figure out what type of filament you're using, what your heater is set to. And so I'm using PETG, and I got a 15 meter retraction, so it's not as stringy as the default. So I kind of tweaked it a little bit. And you output the G-code into your printer, and then on your printer you can either select that from whether you're downloaded through Ethernet, Wi-Fi, thumb drive, however you got your file to your printer, because it's not a PC application, it's a piece of hardware, so you got to get the file there somehow. And then you sit back and you wait, and the printer should print that. The Prusa works like printing PDFs. I mean, what you see is what you get. The Prusa Slicer and the Prusa printer go very well hand in hand, and it doesn't really matter, you know, if you started with a ViaCAD file as a cube and you export. When you export over here, you can pick OBJs, STL files, ASCII or binary, and it'll print those. And an STL file is the simplest. It's what binary is to decimal. It's just all triangles. Okay, so if we take an STL file and we output it, and then we import this STL file, so this is a STL file that was imported, and you'll notice that every face is a triangle. It's no longer like we had our OBJ files, a square. We don't need a square. We try to keep it as simple as possible, and the simplest, smallest polygon is a three-sided polygon. Okay, so this triangle, as we can move up and down and we can pull it in and out. The same thing with this triangle. We can pull this in and out. Okay, so it's good to know that STL files are the simplest form, and they're probably easiest for the slicer to parse. But slicers will take a variety, a handful of different files, and STL is certainly one of the more popular ones. STL does not hold color and textures like OBJs do. STL files are just shape. You're not talking about texture, you're not talking about lighting or anything like that. This will cover part 1. So we gave you some basics of what the workflow is, and now we're going to look at setting up Blender in the next section on how to actually do something. Again, give me a like, a thumbs up, and subscribe to the channel for more information.